Hi class, today's section on solving exponential functions should be pretty short and sweet. We're just going to jump right into examples. So we've talked about exponential growth and decay functions and their graphs, and now we're going to talk about how we can actually solve their equations. So the one thing you want to make sure when you're solving exponential functions, at least for today's section, is that if possible you always want to make the bases equal. And the reason for that is because when you have two bases that are equal, for example, I could have 5 to the x equals 5 to the 4, then what that means is I could go ahead and make my exponents equal to each other. So it's almost like you ignore the bases if they match, and that would just mean x has to equal 4. So anytime you're solving, make your bases congruent and then just set the exponents equal to each other. Okay, so let's jump into this first example here. It says 25 to the 2x plus 3 equals 25 to the 5x minus 9. So again, we'll look at the bases first. Our bases are both 25, so we can go ahead and just work with the exponent. So I'm going to make this exponent equal to this exponent. So 2x plus 3 equals 5x minus 9. And now we can go ahead and solve. I'm going to subtract 2x over to the other side. And that would get us 3 equals 3x minus 9, and then I'm going to go ahead and add 9 to the other side. That's going to get us 12 equals 3x, and then lastly divide by 3, and that's going to get us that x is equal to 4. And you should always be able to plug this back into your equation, and you should get equal sides. So I could have 25 to the 2 times 4 plus 3 should get me the same thing as 25 to the 5 times 4 minus 9. And if it doesn't, then that means that you either need to check your work or there's potentially no solution there. Let's look at example 2. Example 2 has a little bit more steps to it because in this case the bases are not matching. So that means we have to do a little bit of work first. The only way we can really make these matching is by changing the larger base. So if we want to change that base, then we're going to go ahead and rewrite 81 with a base of 9. So I'm going to keep the left side the same, and then I'm going to rewrite 81 as 9 squared, all to the 3x plus 6. By doing that, now I have both bases that are 9, and then I can work with my exponents. The only thing you have to remember is our exponential, or our exponent rules, where when you have a power to a power, you multiply these two things together. So that's actually going to turn into 9 to the 8x minus 4 equals 9, and then if I multiply or distribute, I get to the 6x plus 12. And now we can go ahead and make our exponents equal to each other. So 8x minus 4 equals 6x plus 12, and then I could solve. So if I subtract 6x over, we get 2x minus 4 equals 12. Add 4 over, we get 2x equals 16, and then divide by 2, we get x equals 8, and we'd be finished. Okay, so if the bases don't match, you need to make them match by rewriting one of those bases using exponents. The only other thing, I'm not going to go through an example, but you might see it on your assignments, is that if you have fractions as your bases, you might have to use negative exponents, because remember, if I have 3 to the negative 2, that's the same thing as writing 1 over 9, or 1 to the 3 squared. Okay, so same thing, is just flipping it around and making things positive. So if you need a fraction, you might have to use negative exponents. The last part of this notes is if you are given some equation and you are asked to, or some points, and you're asked to write an exponential function. So here I've got the example of writing an exponential function that goes to the points 0, 3, and 3, 375. So the general form for an exponential function is this here in blue. You should already have that from the last section. And all we're going to be basically doing is plugging in the points and thinking of it kind of like a system of equations. So you're going to plug each set of points in separately, and then you're going to reduce and solve for a and b. So I'm going to start by making sure we remember that these numbers here are the x's and y's. So you don't want to plug them into your a's and b's because those would be different numbers. So let's start with the point 0, 3. I'm going to plug 0 in for x and 3 in for y. So I'd have 3 equals ab to the 0 power. And then I'm going to reduce this down as much as I can. Remember, anything to a 0 power is a 1, so we'd get 3 equals a times 1. And if we divide by 1, we get that a is equal to 3. So already, just because we had a 0 here, we know that a is equal to 3, so this is good. And then I'm going to do the same thing for the other point here. I'm going to plug those x's and y's in. So I'd have 375 equals, we know what a is now, so that would be 3, and then times b to the 3rd power. And now we need to go ahead and solve. So if I divide both sides by 3, these cancel, and I'm left with 125 equals b to the 3rd. And then if you remember your rules for solving with exponents higher than 2, you have to take the cube root. So I'm going to take the cube root of both sides, and that's going to cancel everything on the right side and leave me with b equals, and the cube root of 125 is 5. So now we found what a and b are, and then we can go ahead and write the exponential function. So our final answer would be y is equal to a, which we said was 3, times the b value, which is 5, to the power of x. And remember, when you write your final answers for your functions, you want to make sure you have x and y in your final answer. The a and b should have numbers there. Here's an example that you could go ahead and try, so pause your video, try this one out. It's very similar to example 3, and if you'd like me to check that in class, I would be glad to do that. The only other example that I want to go through is one where you don't have a 0 in your point, and that'd be something like the points 112 and 308. The process is going to be the exact same in terms of solving, but we're going to have a little bit more work because we're not going to have a nice 0 in our exponent. So here, if I plug in my points, I'm going to have 12 equals ab to the 1st. That takes care of the first one. And then I'm also going to plug in over here 108 equals ab to the 3rd. And now I'm going to be solving. Now the problem is I don't have a nice a value or b value that cancels out like I did in example 3 and in example 4. So instead, I'm going to have to do some substitution, and I'm going to work with the lower exponent. That's usually the easiest. What I'm going to do is I'm going to get one of these letters on their own. Usually you're going to get a by itself. So to get a by itself, I'm going to divide both sides by b. These will cancel out, and I'll be left with a is equal to 12 over b. And because I've done that, I know a is equal to this, then I can plug this in here into a in my second equation, and then I'm going to be able to do some solving. So if I do that, I'm going to get 108 equals, and instead of a, I'm going to put 12 over b, and then times b to the 3rd. And now I can reduce, and I have an equation with all one letter in it, which makes it solvable. So if I reduce this, I get 108 equals 12. Now I have b to the 3rd and I have b. B to the 3rd is the same as saying b to the 3rd over 1. So these are actually on the top and bottom, so they're going to cancel, and I'm going to be left with b squared. And now this is something that we can solve pretty easily. So we can divide both sides by 12, and that's going to get us 9. So we're going to have 9 equals b squared, and then we take the square root of both sides, and that gets us b is equal to positive 3. So there's my b value, and then all I have to do is take that b value and plug it back in where I had a, because I don't know what a is yet. So if I plug that back in, I have a is equal to 12 divided by 12 divided by 3, whoops. And if I divide by 3, I get that a is equal to 4. So now I have my a and b, and I could rewrite my final equation as y equals 4 times 3 to the power of x. So notice the key difference here between this example and example 3 was that my exponent did not cancel out when I first plugged in my point. So I had to get one of my letters, a or b, on their own and then substitute it back into the second equation. And by doing that, I got an equation with all of the same variable, and that makes it solvable. So anytime you have 2 letters, try to get an equation with all just one letter, and that makes it much easier to solve for. Okay? If you have any questions on this example, let me know, but that's it for today. Thanks for listening.